Within .NET 8, Microsoft continues to improve upon a brand new compile mode that promises to run your apps 80% faster, as well as decrease the bundle size by around 90%. Now this is a bold claim, however not many people are really using this mode yet. So what we're going to do is take a deep dive into it. We're going to look at the new architecture because it's such a big breakaway from how .NET has always worked, and this really could be the biggest game changer to the framework since .NET Core was released. Now, after we've gone through the theory, we're going to have a look at a practical example. So I'm going to show you how you can set up an API project that makes use of this mode so you can start using it today. Now, if you're a .NET developer, this really is one of those must-watch videos. So spare me 15 minutes and you're going to learn something really, really cool. Before we talk about AOT, let's think about how .NET has always worked since its launch way back in 2002. So, previously in .NET, when you built your code, regardless if you're using C#, Visual Basic, F#, whatever, on build, your code would be converted into something called intermediate language. Now, at a high level, intermediate language, or IL, can be thought of as a coding syntax that is hardware independent. IL is not opinionated or optimized to run on any particular bit of hardware or operating system. Its main purpose then is to be an intermediary step between, say, C# and any operating system hardware combo you decide to host your application on. This is why .NET uses something called the JIT compiler. So the JIT compiler will take the neutral IL code, and then at runtime, when your app first starts, based on the operating system and the hardware the app's running on, it's going to convert the IL code into machine language code that's optimized for the underlying hardware to understand. Now, the benefit of this approach is that you can write your code once and then it can be easily converted and optimized to run on any platform. Well, I say easy, however, I have no idea how to write any of that code myself. I mean, it's easy because Microsoft basically does all the hard work for you. So, in case you haven't guessed, the feature that we're looking at today is called Native AOT deployment, or ahead of time deployment. Now, this feature was originally launched within .NET 7. However, there's also been a bunch of updates in .NET 8 which make it a lot more usable. So, with that said, let's look at how this architecture differs to how .NET has always worked previously. Now, in the new world, AOT changes that existing architecture. So when you compile your code using Native AOT, we're going to be removing that additional IL JIT step. So when you compile your C# code here, you can see it's directly and natively converted into the machine language. So this means that when you're using AOT, you're going to need to specify the target hardware your application will run on at publish. So that all sounds fantastic, I guess, but the big question is, why should we use AOT at all? Well, opting to compile your code natively basically has three main compelling use cases in my opinion. So the first one is that native code can lead to quicker apps. And I think this point is hopefully pretty obvious. No matter how amazing the JIT compiler parses that IL code, adding in an extra step when your application runs will always be slower compared to an application that can run natively. Now, according to Microsoft research, the overall startup time for an app published using AOT can be reduced around 80%. And just to be super clear here, this performance benefit is mainly targeted around the boot up time, because regardless if you're using native or normal JIT and IL, after your app's up and running, performance is going to be really good because .NET is quick. So this is kind of perfect for things like serverless functions. Now, the second big benefit from AOT is that after you do a publish, your end bundle size is going to be much, much smaller. So that all sounds wonderful, but let's see how that actually translates into real world savings. So what I've done is I've got the ASP.NET Core Web API project. I've built one normally and one using AOT, and let's quickly compare folder sizes. So this is the original one. If I do properties, drag this across here, you'll see that this is 205 megabytes. And now if I look in my AOT folder and I do a comparison, you'll see that this one is 150 megabytes. So all the code, everything's the same. The only difference here is the compile mode. So saving 50 megabytes every single time that you need to set up a CI/CD deployment is going to save you a bunch of time at the end of the year. So as you've just seen from my research, I saw a 25% app size reduction when I tried this. However, when we go back to the Microsoft blog, you'll see here that their app size reduction was around 87%. And this is where I got the stats for my very clickbaity thumbnail. And the third and final big benefit of using Native AOT to run your applications is that overall they should consume a smaller memory footprint. Now, the reason for this should hopefully be simple, because an app that needs to load an IL, that needs to run the JIT compiler, is going to consume more memory. Now, this could potentially give you a saving within your infrastructure, because if you've got an app that has more memory spare, then hopefully that should increase its capacity, and who knows, it could save you in your cloud hosting bill at the end of the year. So that obviously all sounds fantastic. However, just like any architecture or anything new and shiny, there's always definitely a few caveats that you need to be aware of up front. Now with AOT, there's a bunch of stuff. So the first one is support. Now currently, there's a bunch of stuff within the .NET framework that isn't supported by AOT. Now this list is pretty big at the moment and it includes delegates, authentication, SignalR, MVC, and Blazor. Now I'm assuming that in the future this list will get smaller and smaller. However, for now you are definitely restricted as to the types of applications that you can use with AOT. Now the second consideration is around the types of target framework that are currently supported. So as of .NET 8, AOT only works on 64-bit processors on Windows, Linux or Mac. If you're trying to do anything on device like iOS, Android or tvOS, you can see there's experimental support, so your app may or may not work. So before jumping headlong into AOT, you definitely want to consider where you're deploying your files to. Now, another downside of AOT that's also worth mentioning is that it makes use of a technique called trimming. Now, many people frown on trimming because trimming will try to remove IL code that is not statically reachable. Now, the danger with trimming is that code can be removed that potentially could be needed at runtime. Now, as the process uses reflection on compile to do its thing, you cannot guarantee what's going to be trimmed. Now, this quote is taken directly from the MSDN docs. If you specify trimming as enabled from the command line, your debugging experience will differ and you may encounter additional bugs in the final product. So, while the future of AOT looks really good, currently you are limited as to what you can use AOT with. Now, for me personally, I think the obvious standout thing is that if you need to create an API project, then AOT is definitely a go-to to consider. So this would obviously be a pretty boring video if we just focused on the theory. So now let's look at how you can actually implement AOT in a project today. Rightio. So in order for you to be able to create a native AOT project, you'll need to make sure that first you have .NET 8 installed. So head over to the Microsoft site if you haven't got it. Secondly, you need to make sure that your Visual Studio is patched to the correct version. So you need to be using 17.8 and onwards. And finally, and this is a big thing, that after you've created your project, if you do not have the development for C++ installed, you're going to get an error. So you can see here that if I went to my Visual Studio installer, which you can just search for from the search bar, if I scroll down to desktop and mobile, you can see here I've got this desktop development with C++ option ticked. And if you don't have this, you're going to get some sort of platform linker error when you try and compile your project later on. And with those prerequisites nailed, we can now create a native AOT solution. So we can do this in Visual Studio or via the CLI. I'm just going to use Visual Studio because it's easier to visualize. So in Visual Studio, go to create a new project. In our search templates, we can just do a search for AOT. And you can see here that we have 2 installation templates we can use. So currently we've got support for a core web API, and we've also got a core gPC service. Now, as a web developer, I don't really use gPC that much, so we're going to create this core web API project. So click on next. You'll see that we can give it a name. Everything's pretty much the same here as a normal .NET API project. Click next again, and then we can create our project, and we're ready to compile code into AOT. So after the project's been created, the files that are generated in the default web API project are exactly the same. The real interesting part comes when we actually try and do a publish. Now that we've got a publish, we've got to set up a profile, and we can set up a bunch of different settings. So how we configure this with the AOT is pretty important. So let's say that I've got my target runtime and I'm going to set it to portable. If I do a publish, you can kind of see here I tested it beforehand. Runtime identifier is required for native compilation. So again, let's see if we update this to say win-x86. If we do save again, if we do a publish, we'll see another error here, hopefully, which says ahead of time compilation is not supported for target runtime identifier win-x86. So this is something you need to consider when you're doing AOT. It's only going to work on the win-x64 architecture. Next, if I do my show settings, you can see that if I do a self-contained, then I set it to win-x64. You can see here I've got .NET 8, I want to do in release, click save, and then if I do a publish, you'll see that my files should hopefully get published successfully after a few seconds. So after we finish publishing, if we look in our build output, you'll see the files here look pretty similar to what you'd probably expect. Now if we go over to Beyond Compare and then compare what our existing project looked like to our native AOT project. Right, so on the left hand side we have our traditional build, and on the right hand side here we have the AOT build. So straight away you can see that we've got a refend, and a static web assets folder, and these are pretty similar. Now within the Win64 folder, things are a little bit different here because we have this native folder in the AOT version, which has this link.rsp, web application 1 ilc.rsp, and a .object. Now aside from that, we have a pub temp, and the difference here is that the output folder here has got a bunch of stuff in, whereas the output folder here only has these 2 JSON files. Then we've got a refend, and a static web assets folder, and these are all fairly similar. Then within the root, again, we've got very similar files. A big difference here though is that you can see we've got this assembly reference cache and a copy complete. We've also got an additional MVC parts assembly info.cs, which we don't have here. Aside from that, we've also got this web application assembly reference cache, another copy complete. So as you'll see, there's a few more files here, but roughly your end output is going to be very similar. So things definitely get a little bit more interesting when we compare the solution DLL. So at the top here, I've got this web application 1, and this is a normal build. And at the bottom, this is our AOT build. So straight away, you can see here that we've got this system runtime compiler services in the second output. And then if we actually compare the IL here, this is our normal build, and in here you can see that we've got all the IL is converting into code. However, if we now look in the AOT version, you can see that we've just got a bunch of machine code in here. So you can see the output is very different when we compare them here, and this new output directly to machine code is where we get all of those big benefits that we've talked about. So then the final task is basically to get those files, whack them on a server, get your app running. And that's basically all you need to do to get started with AOT. It's dead simple, and as I said, it's just a few settings and you can make use of all these amazing benefits. Now, for me personally, I think AOT is going to be a really big game changer for .NET. Now, I've definitely worked on a few projects where API performance has been critical, and because of that, some teams have actually opted to use Go instead, and AOT should hopefully bridge that gap. And it should mean that in the long term, more people should use .NET. Now, as we've seen, AOT still is really new, and there's big gaps in the framework that doesn't have AOT support as of yet. So this means you're not going to be using AOT everywhere, but in the areas that you can do, you should consider it right now. Now, based on that bombshell, before we leave, if you haven't come across this channel before, then my name is John and I release a video every single Sunday aimed at making you a better developer. So don't forget to smash subscribe, hit like, or if you haven't liked this video, instead of just smashing the thumbs down, tell me in the comments what you think I could do to improve my video. Aside from that, I do a free newsletter all about .NET, linked to below. And before we part ways, if you want to learn more about .NET 8, there should be a link on the screen right now to a video recorded all about the best features in .NET 8 and C# 12. Check that out because that's also a good video. Otherwise, until next Sunday, happy coding.